Okay, so this video is going to be the Unit 4G handout, which is only two problems, but they're both pretty long, involved problems, and we're going to use the new calculator tricks to help us figure it out. So let's work our way through number one. So number one, I gave you this line 2x plus y equals 5, which is already graphed for you, and the point P negative 1, 3. And the idea here is that you've got a segment PQ, and the line that's graphed, the purple line there, is the perpendicular bisector of PQ. So the way that perpendicular bisectors work, it's kind of like, let's say I have some segment floating around here, like PQ, or I'll do AB, let's say AB. Then a perpendicular bisector to it has to go right through the middle, right? So this has to be congruent to that, so it bisects, and it has to be perpendicular. So you get right angles here too, right? And then this guy would be the perpendicular bisector of AB. Okay, so what we're going to do is, so the idea is, where's Q, right? Where's Q go? So you can kind of picture, if you drew this accurately, okay, Q should be like somewhere over here, right? Q equals something, comma, something. And we got to figure out where Q is. Well, the hint here is to actually find the equation for PQ. And then you can use that equation with the equation for the original line, and you can end up getting, using your calculator to figure out where they hit each other, where M is. So I'm going to call this midpoint M. So let's see if we can figure out how to do this. So in order to get so the goal is get the equation for PQ. Okay, so first, we'll do this in steps. First step, let's find the slope of the original line. Well, we know that the equation of the original line is 2x plus y equals 5. So if I rearrange it, y is going to be, if I bring the 2x over, it'd be negative 2x plus 5. So the slope of the original line is negative 2. Right? It's the number in front of the x term. So I'm just going to put right here, slope is negative 2. Okay, well, that means that the slope, so we'll say find slope of the perpendicular bisector. Well, the slope of the perpendicular bisector is going to be the negative reciprocal of this slope. So the previous slope was negative 2, which means the slope of oh, sorry, not the slope of the perpendicular bisector, the slope of PQ is going to be the negative reciprocal of negative 2, which is positive 1/2. That's the PQ. I'll do a little PQ. Okay. And then the third thing is find the equation of PQ. So I'll put right here, this guy's slope is 1/2. Okay. I'll do this. Okay, so we want the equation of PQ. We'll use point slope form. Y minus y1 equals m x minus x1. All right. We know the slope is 1/2. And then it's x1, y1 is any point on your line, but we only know this point, negative 1, so that becomes plus 1, and 3, so 3 goes there. So here's the equation of PQ. All right, so now we want to use the calculator to graph the lines and find the intersection. So here's the calculator, and I'll turn it on here. Of course, it won't turn on. There we go. So the way to enter in the equations you want to graph, you go to y equals, which is up in the top corner here. Y equals. Okay. So I have two equations entered. The only problem is that it has to be y by itself. Well, here's the original line with y by itself. So I'm going to scroll down a little bit here. I'm going to say y1 equals negative 2x plus 5. And then y2 will be the other line, which is this one. And that, to get y by itself, I have to add 3 to both sides. So it's going to be 1/2 x plus 1 plus 3. Okay, so I'm going to enter those into the calculator. So negative 2, remember to use the negative, not the minus. Negative 2. And then the x button is this shortcut right here, where it says xt theta n. So there's x plus 5. And then in y2, I'm going to do a half. You could just do 1 divided by 2. But if you like the fractions, remember it's alpha f1, numerator over denominator, 1 over 2. And then x plus 1 plus 3. Okay, so there are my two lines. If I hit graph, it should graph them. So there's one of them. And there's the other one. Now my guess is this isn't quite how it shows up on most calculators. In order to get the most normal looking window that you can get, it's if you go to zoom and then pick zoom standard, Z standard, this is what most of your calculators will look like. So there's the first line, that's the original. There's PQ, if it kept going in both directions. And if you look at it, it doesn't look like a right angle, even though it should. And the reason for that is that it's stretched differently this way than it is that way. So what you need to do is, if you go back to zoom and you choose zoom square, that actually makes angles look correct. Everything's zoomed appropriately then. So when we regraph it, it'll actually look like it forms a right angle. So there it is. Okay, now the place where they cross, that's M right here. So the goal is to figure out where M is, because if I know where M is, then I can figure out where Q is. So the calculator can do that for you. So the way to do it is we're going to go to the calculate menu, which is second, and then you find calc, and then we're going to choose the feature called intersect. So it's second, and then notice calc's in blue here, which is why I hit the blue button first. Calc, and then option 5 for intersect. So again, I'll go back to the graph. It's second, calc, second, calc, intersect, number 5. Okay, and then it asks 3 questions. First curve, then it'll say second curve, and then guess. First curve means just mark the first line that it's on, right? It needs you to tell you, it needs you to tell it which 2 lines you want it to look at, because it doesn't know how many lines there are. So I'm going to mark the blue one, hit enter. Notice it leaves a little mark. And then it says second curve. So I tell it, okay, I want you to also look at this line. So you hit enter. And then for guess, you just move it kind of close to where they actually intersect and you hit enter. There it is, 0.6, 3.8. So I'll put down here first curve. So enter for first curve. Enter for second curve. Enter for guess. And then you get the intersection point. Whoa. And it should say the word intersection with the X and the Y values. So intersection is going to be 0.6, comma 3.8. Okay. So I'm going to exit back out here, scroll back up. So that means where M is the point 0.6, 3.8. Okay, let me zoom in a little bit on this. Let's go 150. All right. Well, the goal is to figure out where Q is. I know M is the midpoint of PQ. So if I could figure out how to get from P to M, I could repeat the process to get from M to Q. So let's figure out how to get from P to M and then repeat it to get to Q. Okay, so I know the coordinates for P and I know the coordinates for M. So to get from P to M, when I go up, only the y's change from 3 to 3.8. So that's 0.8 units up. To go across, the x's change from -1 to positive 0.6. So that's from -1 to positive 0.6, I had to go 1.6 to the right. So that's to get from P to M, which means to get from M to Q, I'm going to go up another 0.8 and over another 1.6. So if I go up another 0.8, then the y's change, I have to add 0.8 to 3.8, and that ends up being 4.6. And then when I go to the right, I'm going to have to increase where I was, which was 0.6, by 1.6. So 0.6 plus 1.6, 2.2. So there's my Q. So I'll come back down here. Let's go back to normal. So the fifth step here would be, so the intersection is M in this case. So what I did was I figured out how to get from P to M and repeat to get from M to Q. Okay? All right. So hopefully that helps a little bit. We're just using the slope triangles right there to help us. Okay, let's try number 2. So in this one, the median is the new term here. Median of a triangle is a segment that starts at one vertex and goes to the midpoint of the opposite side. So the first thing that we're doing here is find the coordinates of the midpoints of AB, BC, and AC. Okay, so let's do that. A, midpoint of AB. We'll call this one M. Well, the midpoint formula is just average the endpoints. So A is here, B is here. I want to average -9 plus 0, so average the x's, divide by 2, and average the y's, 1 plus 5 over 2. So that's going to be -4.5, comma 3. So there's M, -4.5, comma 3, which is right about here. Okay, there's M. Let's do the midpoint of BC, and we'll call that one N. So midpoint of BC is N, and B is 0, 5, and C is 6, 0. So if I average the x's, 0 plus 6 over 2, and then average the y's, 5 plus 0 over 2, then I'm going to get 3, comma 2.5. So 3, 2.5 is N. And then we'll do midpoint of AC, and I'll call that one P because O looks like 0. So the x's are -9 and 6, and the y's are 1 and 0, so I'll average those. And if I do that, I get, let's see, -3 over 2 is -1.5, and 1 over 2 is 0.5. So -1.5 would be right there. P, -1.5, 0.5. Okay, so now we need the equations of the medians of the triangle ABC. Okay, well, the median goes from a corner to the vertex of the opposite side. So first, we'll do them in the same order that we did before. So midpoint of AB first. So let me do this. Okay, so we found M, so we're going to do C to M. Right there. So we want the equation of that red line. Okay, so equation of median from C, vertex C. Okay, so we'll use point slope form. And what we need is the slope, really. So the slope, you can draw in a slope triangle if you want, but I'm going to end up erasing this anyway. When I go up and down, the y's change. So I was at 3 and I went to 0. So that's a drop of 3. And then across, I went from negative 4.5 to 6. So negative 4.5 to positive 6 is 10.5. And notice the red line is going downhill, so it's negative. Okay, and I've got x minus something and y minus something, and you get to pick any point on the red line. Well, any point I want on the red line, I can either pick this one or that one, and 6, 0 looks easier to me. So I'm going to put the 6 here and the 0 there. So there's the median from C. Here's the equation right there. Okay, let's do the equation of the median. Equation of the median from A, because that's AN. So there's that one. Okay, well, let's see, we need the slope. First I'll write this, y minus y1 equals m x minus x1. So the slope, let's see, I started at negative 9, 1, and I went up, and so the y's change when I go up, 1 to 2.5, so up 1.5, and over from negative 9 to 3, so over 12. And I'm not going to bother reducing that or simplifying it at all, because the calculator will take care of that stuff for me. Okay, so we've got x minus something, y minus something. Well, 3, 2.5 or negative 9, 1, I prefer not doing decimals, so let's do negative 9, 1. So this becomes plus 9 and minus 1. So there's the green median from A to N. Okay, so then we got one more median to do, and I'll do that one in gray. So here's the third median right here. Right there, from B to P. Okay, so the equation of the median from B. So y minus y1 equals m, x minus x1. All right, well the slope is what we need. So if I start at B, I have to go down from 5 to 0.5. So I went down 4.5. And I had to go backwards from 0 to negative 1.5, so that's 1.5. And the overall line is going uphill, so it's a positive slope. So it's x minus something, y minus something. Well, I think B is an easier point than P to use. So I'm going to say x minus 0, y minus 5. So there's that equation right there. Okay, so I've got my 3 equations. So that's part B. That's a long part B. Okay. So C says the 3 medians should all be concurrent, meaning they all hit at the same point. By the way, it's called the centroid where they hit. This point right here. Centroid. Intersection of the medians. Okay, so we want to find the coordinates of where they intersect. All right, well to do that, we can use our calculator because we have all 3 of these equations. So let me open up the calculator again. And I'm going to enter in the 3 equations. Now the 3 equations that I'm going to enter in have to be in y equals form. So y1, this one is basically already in y equals form. I'll just do negative 3 over 10.5. X minus 6, and then the 0 goes away. y2, I'll do 1.5 over 12 times x plus 9, and then add the 1 over to the other side. And then y3 will be 4.5 over 1.5, x minus 0, or just x, and then add the 5 over. Okay, so let's graph those three lines. Clear, clear. So we've got -3 divided by 10.5, parentheses, x minus 6. So there's the first line. Second line is 1.5 divided by 12, parentheses, x plus 9, close parentheses, plus 1. And the third one is 4.5 plus, or sorry, not 4.5. 4.5 divided by 1.5, parentheses, x minus 0, so I'm just going to write x, plus 5. So if I graph it, I should get the same three lines that are in the previous diagram there. So let's graph it and see. So that blue line is actually the red line right here. The red line is actually the green line right here. And then there's the one that's gray in the picture over here. Okay, so we want to find out where do they cross. So remember, to find out where they cross, we're going to do second, calc, intersect. And then it asks you three questions, right? It's going to say first curve, second curve, and guess. It doesn't know that you have three lines there. It doesn't know which, and it can only handle two at a time. But since they all cross at the same point, then you can just pick whichever two lines you want as long as they're different. So we'll go second, and then there's calc, and then there's intersect, so 5. And I'll mark the blue line, and then I might as well just mark the red line, enter, and then guess. So I'll move it close and hit enter. And there's the intersection, -1, 2. So the centroid is going to be -1, 2. Now if you wanted to make absolutely sure that that was it, you could try picking two different lines instead. So we'll try that real quick. Second calc, 5 for intersect. And then I'll pick the blue and the black line instead. So there's blue. And then black line, I had to hit up and down to get to the black line and hit enter. So I'm looking at the intersection of blue and black. And then if I scroll over to the close to where it is and guess there, yep, still -1, 2. Okay. So I hope that helps a little bit.